Welcome to The Explainer. I'm so thrilled you're here. We're jumping right in today, and our goal is to break down the core pedagogical strategies used to teach young learners the absolute fundamentals of math. It's a genuinely fascinating look at how we take highly abstract concepts, symbols and logic that just feel like second nature to us adults now, and literally construct them from the ground up. We'll see how educators ensure strong comprehension of basic math through really engaging, hands-on learning experiences.
Okay, let's dive into this, because think about it. This is the fundamental challenge educators face, right? How exactly do you teach a young mind to understand abstract numbers? A child naturally lacks the cognitive framework for abstract quantities. To them, a number on a blank page is, well, it's just a meaningless scribble. There's no weight to it. The source materials we're looking at tackle this head-on through a process essentially known as cognitive offloading. By utilizing visual aids and physical interactive formats, educators take the mental strain off the child. They give those abstract symbols an immediate, tangible reality.
Section 1. Foundations of Numbers. Building the ground floor. Before a child can even begin to manipulate numbers, they have to establish exactly what they are and how they behave. The foundational sources focus first on what is actually a monumental task for a young learner, and that's counting up to 100. Reaching that number is a massive cognitive milestone. To us, it's just 100. To a toddler, 100 is an intimidating, abstract mountain. It's not just about memorizing a sequence of sounds. It's about establishing a really deep understanding of quantity and scale. And to manage that, the materials rely on a very specific, highly effective strategy.
So the crucial point is place value. To make sense of numbers up to 100, the educational material explains how numbers are literally built using tens and ones. Why does this work so brilliantly? Well, because rather than forcing a child to memorize 100 individual, totally disparate digits, it creates logical, predictable patterns that the young brain can easily recognize and scale up. By grouping objects together into bundles of 10, visual aids transform a giant, scary number into manageable, structured, bite-sized groups. Section 2. Combining groups. The build-up with addition.
Once that groundwork is totally laid, we reach the next logical progression in our narrative. We're taking those foundational numbers and we're starting to bring them together. The educational material defines it straight up. Addition means combining different groups to find a total sum. But the real insight here is how the learning material shifts from static observation to dynamic action. Addition isn't taught as a dry, boring math problem. It's presented as a physical event. You are visually combining groups of animated objects. It is highly interactive, which makes absolutely sure the concept is rooted in observable, real-world action.
Section 3. Taking things away. The breakdown with subtraction.
But what goes up must come down. The source material playfully calls this making it less, super subtraction, and introduces the concept for numbers within 20. And this brilliantly illustrates the core difference young learners have to grasp. On one side, we have addition, combining different groups. On the flip side, subtraction, taking away from a group. Seeing them side by side like this reinforces that they are inverse operations. Grasping this inverse relationship is another huge milestone. You're either building the group up or you're breaking the group down. It's two sides of the exact same coin. To really make this stick, the learning materials use incredibly relatable scenarios. I want you to imagine the number 5. Actually, more specifically, imagine 5 delicious, freshly baked cookies sitting on a plate. Let's move along and see how this builds. The material gives us a wonderful animation sequence to illustrate this whole concept. Step 1, those 5 delicious cookies are sitting there on a plate. Step 2, a child takes a bite, and boom, 1 cookie disappears. As the learner mentally processes the cookie disappearing, the source material instantly maps that reality to an abstract equation. 5 minus 1 equals 4. Then, step 4. Another cookie disappears, and the equation updates. The visual reinforces the math symbol in real time. It directly ties the physical act of taking something away to the mathematical logic, seamlessly linking the mental reality to the abstract equation. Section 4. Real-life math applications. Making it stick. To truly grasp these concepts, the learning material relies heavily on interactive, story-driven methods. Now, what's really interesting here is how narrative is used. The material references the mouse count story. In it, a snake is collecting mice, making the number go up, but then the clever mice escape the jar. As they leave, the student counts backward to find out how many are left. The absolute genius of this approach is how it uses a narrative to teach operations. It basically sneaks a math drill inside a high-stakes, engaging story,
proving that context and narrative drive retention far better than rote memorization ever could. The sources also outline another practical application, an interactive game featuring a character named Professor Pixel. Here, the student helps share candies, subtracting to see exactly what is left for the professor. What elevates this concept is that it relies heavily on student agency. By forcing the child to actively distribute the candies themselves, the pedagogy shifts from passive observation to active problem solving. It takes the abstract mathematical operation and turns it into a tangible, interactive problem that completely empowers the student. It all comes back to building a strong comprehension of basic math through accessible and hands-on learning. Whether it's grouping tens and ones, matching a disappearing cookie to a real-time equation, or using student agency to solve narrative puzzles, these cognitive hooks are absolutely essential. Which leaves us with a final thought to ponder based on everything we've unpacked today. How do these foundational, hands-on experiences shape our lifelong relationship with numbers? Thank you so much for joining me for this explainer. Keep learning, keep visualizing, and I'll catch you next time.